In this tutorial, we will be covering the basics of an autonomous linear op mode. If you're using OnBotJava, go up to the plus sign on the top left, name the file, and then click Autonomous. If you're using Android Studio, right-click on the file system to the left of the screen and select Create File. You'll see that there will be code automatically generated. Keep this for the time being. Add after the class declaration extends LinearOpMode. This allows us to access the functions that are given to us by first in order to control our robot. On your control hub, you will see 4 ports for the motors. If you have a functioning robot, make note of where the motors are plugged in. On the driver app, go up to the 3 dots in the top right. Then select New and follow the menus until you find the motor selection. You will want to name your motor something understandable. We are showcasing a basic 4-wheel design. We are going to be starting on the 0 port and labeling it in the app. If it's your bottom left motor, label it back left. If it's your top right, label it top right. Then exit out of the menu and save the configuration. Refer to the diagram for what to label them. You can name them whatever you want, but you will need to reference these labels in code, so make sure they're understandable and memorable. Then exit out of the menu and save the configuration. One thing we like to do is write down in this diagram and tape it to the control hub. This ensures that our entire team knows where to plug in the motors and saves a lot of strange debugging. Below the class line, add DC motor in the label you added. We will add DC motor back left, then repeat this for all 4 motors. This defines the variables that we will be accessing later. There are a few methods you can utilize, however for a linear autonomous we'll only be utilizing 3 of them. Methods are just how we wrap the code in order for the app to know when to execute them, as well as access advanced behavior the app gives us. This method will run when the init on the driver app is clicked and will contain our logic for our autonomous drive. If you're using Android Studio, you can use autocomplete to make a lot of this easier, but you might have to type it in fully if you are using OnBotJava. While we've defined the variables, we haven't given them a value yet. Add your variable name with equals hardwaremap.get in parentheses dcmotor.class, your label. You will have to reverse the motors. We're going to be reversing the right side. Add backleft.setDirections in parentheses dcmotor.directions.reverse. Then do the same for the front left variable. First, add the function wait for start. This function halts the program until the play button on the driver hub is pressed. We will want to set the power of all of our motors. Do backleft.setPower 0.5. This will move the back left motor at 1/2 of its total speed. Copy and paste this line 4 times and replace the variable name for each wheel. Then add the function called sleep. Inside this function, we will add the total number of milliseconds we wish to sleep for. I will be adding 500 milliseconds. Finally, copy and paste the block we added to move it forwards, but instead replace the numbers with zeros. If you have a functioning robot, test the op mode now. It should move forward for 1/2 second, then stop. Remember earlier when we made variables for all the motors? We're going to make similar variables for the speed of the motors. When you define the motors, add double motor speed equals 0.5. Now go to the motor block and replace 0.5 with motor speed. Try the op mode again. If you want the robot to move faster, replace 0.5 with 0.6 or 0.7. To go slower, replace it with 0.4 or 0.3. For our last step, we'll cover turning. Copy and paste the motor block and replace either the right or left motor speed reference with negative motor speed. This will be the end of our tutorial. However, often top autonomies aren't written like this. Instead of being time-based, they are instead based on complex conditions or use libraries such as roadrunners in order to control the robot. We will be covering some of these topics in a later video.